Good morning, still morning. How's everyone doing? All right, so I will be speaking about service providers' experience of deploying OpenStack Cloud. And yes, my name is Toni Kalombo. A little bit about me. I've worked in multiple industries, applying my trade as a software engineer, and I have also been involved with a few companies, either as in consultation or working for some of the companies there, such as BMW, the CSR, and MTN. So I'll speak a little bit about my virtualization story. I graduated as an electronic engineer, and I was pretty much, I have quite a passion for electronics, and I built that passion from a young age. So if you came in my room, there'll be all sorts of electronic circuits and breadboards sitting around, and I pretty much spent my teenage years tinkering with electronics. As I progressed in university, you know, we'd follow I got involved in micro electronics, where we'd build microprocessors. And the process of microelectronics pretty much is you have a mathematical model, and you build that mathematical model, and then you build the software simulation to validate your mathematical model. Once you validated your mathematical model, then you'll etch that microprocessor into an actual physical circuit. I found myself stuck in the middle, you know, doing the software simulation, and I totally enjoyed that. That was a good maybe 15 years ago, but coming here, it makes me realize that the technology trend is moving towards virtualization, and where the physical becomes less relevant because you can pretty much virtualize everything. You know, for instance, if you think about artificial intelligence, we're pretty much trying to virtualize the human brain. So, which brings me to SEACOM. And as a software architect at SEACOM, just to speak a little bit about SEACOM, I'm sure everybody knows we're a Pan-African service provider, and we are a broadband submarine cable system, and we provide various services like IPL transmission, Ethernet services, and internet connectivity, mostly for the southern and the eastern African regions. One of the things that I like about working at SEACOM is that our services are really advocating for open access. So no shaping, no throttling, and you buy your bandwidth and you get exactly what you're paying for. So I like the idea of not being restricted, and that is what open access and open standards and open technologies are trying to advocate for. So the challenge that we have as network operators is that we need to evolve. That evolution generally speaks to the ability to develop new services and to increase your revenue exponentially. So that means that you get the more customers you get with the same amount of headcount. So therefore you need to find ways to optimize on the way that you provide your services. Of course, you also want to provide value to your customers, and we have quite a focus on enterprise, small medium enterprises. As a network operator, we purchase network equipment, and you sort of would like to reduce the cost of your equipment so that you can provide better value to your customers as well. So that means that you improve your operational processes, and you provide more efficiency by reducing the amount of time that you spend delivering services and provisioning and deploying physical bare metal devices in data centers or on customer premises. So one of the things that you also want to do is when you purchase your hardware or the services that you provide to your customers, your infrastructure, that you do not want to be locked into a vendor, because that means that you do not have the agility to change and to adapt to the market as new technologies evolve. And of course, in all of this is you want to give the customer freedom to customize the products that they buy, and you don't want to be locked into a fixed product model, because you also want to be agile enough to react to your customers' needs. And being in a technology space, our customers' needs evolve pretty quickly, and we need to keep up with that. So enters OpenStack. What is OpenStack? So OpenStack is a cloud operating system, and it also allows one to control compute storage and networking resources, and it provides a dashboard for admin control. It has API interfaces. Being open standards, you have open API, you have access to terminal or CLI for the more technically inclined engineers. So why would we go the OpenStack route? One, we want to be able to have open standards so that any of the services that you have on your OpenStack cloud are actually open and not closed due to proprietary vendor technologies. So now it puts you in a position where you can ask your vendors to abide to open standards instead of you as the customer having to abide to the vendor standards. And therefore it gives you a bit more room and a bit more agility to be able to react to the market. So the opportunities that OpenStack provides, of course, is virtualization and infrastructure management platform. So that means that for your physical network elements, you now have the ability to take that physical world and virtualize it. So by virtualizing, you can exponentially increase the resources that you provide to your customers without having to rely on the physical constraints of data centers or of just delivering physical hardware and the entire procurement process that entails having to purchase physical hardware. So by virtualizing, you now also have the ability to manage your network in a more automated manner. And that brings about the idea of software-defined networking, where through software-defined networking, you actually have a separation of the control plane and the data plane, and you have better control over the resources that you consume over your network. And of course, one of the advantages of OpenStack is that you are no longer confined to a proprietary vendor's hardware, but you can purchase commercial off-the-shelf hardware and optimize on that. All right, so with that said, so OpenStack pretty much this is based on the ETSIs and the OpenNFV diagram, which speaks about the NFV architecture. And pretty much network function virtualization it's pretty much a stack. And in that stack, we have the OpenStack, which is just one component of the entire virtualization platform. So what you would like to do is to have OpenStack be as the virtual infrastructure manager for your compute, storage, and networking. And you have the physical compute, storage, networking, and you also have the virtualized compute, storage, and networking. With that said, you'd have your hypervisor plane. You'd have on your storage, you'd use something such as Ceph for storage, and then you use a lot of open standard for your networking, such as Open Virtual Switch or Open Daylight, which are projects that are focused at promoting open standards when it comes to networking technology. So with all that theory, now we have to go and deploy OpenStack. When you come to talks like this, everyone tells you about how great it is and how great it is to embrace these new technologies. But in practice, it's actually quite challenging, and the challenges tend to be less technical and more what I call the early adopter dilemma. In a nutshell, as an early adopter, you sometimes don't know what you don't know. Being a new technology, you sort of have to feel your way around, you know. It's like Microsoft releasing the first tablet and it not kicking off, and then Apple coming in a few years later and pretty much revolutionizing with the iPhone and the iPad. And being an early adopter has that challenge of not timing correctly and not really understanding what the market wants or needs. So one of the things that we've tried to do is to educate ourselves a little bit more about the technology that we're investing in. So attending conferences, speaking to other people who are playing in the same field and the same market, meeting up with vendors of the technologies, reading up about it, doing research, so getting involved in some research bodies and actually contributing to the community as well, just so that, one, there's better understanding, and two, you can also have an influence on the trends and the growth of the technology that you're investing in, and of course being certified as well. Certification allows for good practices, best practices, and it allows for standards and recognition of the skills or the skill set that you build up. And as I said as well, through the research, you also make affiliations in the industry. So for me, I feel that once you have a good grasp and understanding of the technology, then you're in a better position to start making decisions about the technology that you invest in. So what we then did after the whole exercise of educating ourselves about network function virtualization, OpenStack, software-defined networking, is that we started speaking to the established players. So we put out an RFI for SDN to the likes of Cisco, Juniper, Exxon, Arista, Sienna, and a few other companies. One, just so that we understand where they stand in the market and to see what opportunities that there are. We found that software-defined networking, SDN, is not, in my personal opinion, there's still quite a lot of work to be done in the SDN space, and I feel that there's still a lot of maturing to be done. But in the network function virtualization space, I felt that there was a whole lot more maturity in terms of the kinds of services that you can host on virtualized network functions. So with that said, one of the findings from the RFIs is, of course, that by going with one of the established players is that because this is such a fast emerging and new technology, we may not always have the ability to adapt in an agile manner if the trends in technology change. So there's already a few groups and bodies that are invested in developing NFV and SDN, and there isn't always agreement as to where technology will go. And you cannot always define, dictate, or predict where technology trends will go. So best is to put yourself in a position where you can actually be able to be nimble enough to adapt. Enters the open source vendors or just open source technology. One of the advantages of open source technology, I believe, is that because there are communities that are constantly working on these technologies, they are actually in a better position to be agile and to adapt to the changes. So we went with Canonical as a partner to enable us to deploy Ubuntu. So we decided that our OpenStack cloud would be on Ubuntu after evaluating a few other open source vendors. And we learned a few things about how to set up a contract for a technology that a few have tried. And the kind of things that you need to look out for. You've got to spell out the very technical intricacies, because if you don't, once you deploy, you start learning the things that you didn't know. One of the problems that we had was with the hardware, having to purchase additional hardware, having to purchase additional switches, having to improve our port capacity from 1 to 10 gigs, and just to allow for better communication on the storage networking part. And pretty much that's a snapshot of our infrastructure, and this is just the basic that we needed to get started. And we pretty much used Dell, and we used 13 Dell Blade servers and 3 Dell PowerEdge servers for the storage. And just a snapshot of the environment using Ubuntu, which uses Metal as a service, as well as the Juju controller for DevOps and automatic deployment. And just a snapshot as well of the specs around the versions of the software that we use, using OpenStack or Kata. And on the networking side, one of the biggest challenges and one of the things that really took time was setting up the actual, the logical network topology and the different types of networks necessary to get a proper production-based OpenStack cloud going. And so some of the challenges, of course, was the time for delivering hardware, the need for additional servers and switches when you realize that you needed to expand a bit more. Simple things like your out-of-band management has to be very specific when you deploy OpenStack. The VLAN configuration. For instance, we spent about 3 weeks trying to figure out why we couldn't access ports, and it turned out that we had partitioning on the NIC, on the out-of-band management part on Dell. People management, getting multiple teams to work together, and also, because it's a new skill, getting people to actually understand what they need to do. Of course, it's a specialized skill set, so skills such as Linux, IP engineering, and cloud engineering are essential to deploy an OpenStack cloud. Some of the opportunities of this is that we can now onboard virtual network functions. We can enable software-defined networking. We can actually do tests on virtual network functions from multiple vendors, because we now have a cloud that is open, that is based on open standards and is open to any vendor who plays in this space. So that means that we can actually test out the different functionality without being restricted to purchasing from a single vendor. Of course, we have scalability, high availability, which is inherent with cloud infrastructure. One of the advantages now is that our operations is enabled a bit more because we can automate our resources. So there's a strong focus on DevOps that we now have to pay attention to. And of course, integration into our OSS and our BSS, giving us the ability to let our customers provision on the fly, and the time to market. Just some of the next steps and some of the products that we are looking at, like virtual CPEs, firewall routing, bandwidth on demand, and as I said, thinking DevOps. And that's it. Any questions?
I'm going to ask that we keep questions till after Malcolm's spoken, because Malcolm's talking on a very similar topic. So thank you very much, Tony, and we'll have some question time after Malcolm.